Okay, students. കഴിഞ്ഞ ക്ലാസ്സിൽ നമുക്കറിയാം ഒരു ചാർജ് പാർട്ടിക്കിളിനെ പെർപെൻഡിക്കുലർ മാഗ്നെറ്റിക് ഫീൽഡ് അറിയാണെങ്കിൽ it will execute a rotational motion. Now in this class we are going to speak about a charge particle moving at an angle which is not 0 and not 90 degree. That is, if a charge particle is thrown at an angle which is less than 90 degree and at this that is not 0, for which we are having our x-axis like this and y-axis like this, and let this be our z-axis. In the x-axis we are having the magnetic field. Our magnetic field is along the x-axis. Then let this be our y-axis and z-axis. We are having a positive charge particle at origin. It is thrown with an initial velocity v like this. It is making, that is the initial velocity is making an angle theta with respect to the external magnetic field. The initial velocity is making an angle theta with respect to external magnetic field. What will happen to the motion of this charge particle? We have to discuss this particular situation. In order to discuss this particular situation, this velocity is not parallel to magnetic field or perpendicular to magnetic field. Therefore, initially we are going to resolve this velocity. Let us resolve this velocity. In order to resolve this velocity, we are resolving this velocity into a horizontal component that is parallel to magnetic field and a vertical component which is perpendicular to magnetic field. Therefore, this component is the V parallel component, and since this angle is theta, we could say this is V cos theta. The component which is parallel to velocity, or the component which is near to the angle, is called as V cos theta. This component is V cos theta. Then this is the component of velocity which is perpendicular to the magnetic field. The component of velocity which is perpendicular to magnetic field, and it is V sin theta. As we have learned, the component which is near to angle is cos theta component, and the component which is not near to angle is sin theta component. This is our V sin theta component. Then in this particular situation, what's happening is the V cos theta component, it is trying to move the charge particle in x direction. The V cos theta component is trying to move the charge particle in x direction, and the V sin theta component is trying to rotate it. The component which is perpendicular to magnetic field will try to rotate it. The component which is parallel to magnetic field will try to move it forward. Therefore, the combined effect will create a motion like this. The combined effect will create a motion like this means it will move in a helical path. Let me draw the path. That is, the charge particle will move in a helix like this. It will move in a helix like this. That is, assume that we are having a spring. Spring കണ്ടിട്ടില്ലേ? സ്പ്രിങ്ങിന്റെ രീതിയിൽ it will move in a helix like this. Okay. Therefore, the component which is parallel will try to move it forward. The component which is perpendicular will try to move it in a circular path. The combined effect will create a helical motion like this. Therefore, the charge particle which is thrown at an angle which is less than 90 degree will move in a helical motion. Let's rewind the situations. If a charge particle is moving in a perpendicular magnetic field, it will rotate. If a charge particle is moving in a perpendicular magnetic field, it will rotate. And if the charge particle is moving in a magnetic field at an angle with the magnetic field, it will move in a helical path. What will happen to the charge particle which is moving in a parallel magnetic field? If a charge particle is moving in a parallel magnetic field, it will translate. അതായത് മാഗ്നറ്റിക് ഫീൽഡിന് പാരലൽ ആയിട്ടാണ് ചാർജ് പാർട്ടിക്കിൾ എറിയുന്നത് വെച്ചാൽ ആ ചാർജ് പാർട്ടിക്കിളിന്റെ മേലെ മാഗ്നറ്റിക് ലോറൻസ് ഫോഴ്സ് ഉണ്ടാവോ? ഇല്ല. കാരണം the angle theta will be 0 degree. The angle theta 0 degree means it will move in a straight line, that it will be translate. Magnetic field perpendicular ആയിട്ടാണ് നീങ്ങുന്നത് വെച്ചാൽ അതെന്ത് ചെയ്യും? റൊട്ടേറ്റ്. Okay, അപ്പം ആ കാര്യങ്ങളൊക്കെ നമുക്കറിയാം. Therefore, in this case, it's moving in a helical motion, and if it is moving in a helical motion, we will have to find out the pitch of the helix. We will have to find out the pitch of the helix. Pitch means the linear displacement undergone by the particle on completing one revolution. The linear displacement undergone by the particle on completing one revolution. അതായത് if we are having a substance over here, ഒരു കംപ്ലീറ്റ് റെവല്യൂഷൻ ചെയ്യുമ്പോഴേക്കും ഒരു സബ്സ്റ്റൻസ് ഇവിടെ ഉണ്ട്, ഒരു കംപ്ലീറ്റ് റെവല്യൂഷൻ ചെയ്യുമ്പോഴേക്കും അത് കുറച്ച് ലീനിയർ ഡിസ്റ്റൻസ് നീങ്ങും അല്ലെ? ഒരു കംപ്ലീറ്റ് റെവല്യൂഷൻ ചെയ്യുമ്പോഴേക്കും ലീനിയർ ഡിസ്റ്റൻസ് നീങ്ങും. The linear distance undergone by the particle on completing one revolution is called as pitch of the helix. ഇവിടെ നോക്കിക്കോ, if you are looking over here, if the particle is starting from here, on completing one revolution, it will have to reach over here. ഒരു revolution ചെയ്യുമ്പം അത് ഇവിടെ നിന്ന് ഇവിടെ എത്തിയിട്ടുണ്ടാവും. Then the linear displacement completed on one revolution is this, and this distance, let's call it as x. X is called as the pitch of the helix. What is pitch of the helix? The linear displacement undergone by the particle on completing one revolution. It is pitch of the helix, and the expression for pitch of the helix, that is distance ആണ്. Distance can be written as velocity into time. Since velocity is equal to displacement by time, displacement can be written as velocity into time. And in this case, we could write pitch of the helix as which velocity is moving it in the x direction. Velocity യുടെ ഏത് component ആണ് അതിനെ മുന്നോട്ട് നീക്കുന്നത്? The v cos theta component or the v parallel component is pulling it in the x direction. It is translating it. Therefore, the velocity that we have to take will be v parallel into time will be time period. V parallel into t. കാരണം v parallel ആണ് അതിനെ മുന്നോട്ടേക്ക് നീക്കുന്നത്. The time taken for one complete revolution is time period. Therefore, pitch is equal to v parallel into t, and v parallel can be denoted as v cos theta. Can you recall the expression for time period? Time period was 2 pi m by qb. The time period of a particle executing circular motion 2 pi m by qb ആണ്. ഇവിടെയുള്ള time period 2 pi m by qb ആണ്. കാരണം time period is independent of velocity. Velocity നെ ഡിപെൻഡ് ചെയ്യുന്നില്ല. അതുകൊണ്ട് ഇവിടെയും time period 2 pi m divided by qb. Then we could write pitch of the helix as 2 pi mv cos theta divided by qb. 2 pi mv cos theta divided by qb. This is the expression for pitch of the helix. Okay, therefore, what is the expression for pitch of the helix? It is 2 pi mv cos theta divided by qb. What is pitch? It is the linear displacement undergone by the particle on completing one revolution. One revolution complete ചെയ്യുമ്പം undergo in a linear displacement. Okay, therefore, now we have understood the pitch of the helix. Then we have to determine the radius of the helix. അതായത് ഒരു സ്പ്രിങ് നീങ്ങുന്ന, സ്പ്രിങ്ങിന്റെ മേലെ കൂടെ ഒരു ചാർജ് നീങ്ങുന്ന വരെയാണ് നീങ്ങുന്നതെങ്കിൽ ആ സ്പ്രിങ്ങിന് ഒരു റേഡിയസ് ഉണ്ടാവില്ലേ, ക്രോസ് സെക്ഷണൽ റേഡിയസ് ഉണ്ടാവും. Therefore, in order to find out the radius of the helix, can you recall the radius of the circular motion if the charge particle is moving in a perpendicular magnetic field? Perpendicular magnetic field ആണ് നീങ്ങുന്നത് വെച്ചാൽ അതിന്റെ റേഡിയസിനെ നമ്മൾ r is equal to mv by qb. We have learned an expression like this in our previous session. That is the radius of the circular path. R is equal to mv by qb. In this case, what we can say is the radius in this case will be which component of velocity is trying to rotate it. ഇതിനെ rotate ചെയ്യാൻ സഹായിക്കുന്നത് v sin theta component അല്ലെ v perpendicular component ആണ്. Therefore r should be written as mv perpendicular divided by qb. What is v perpendicular? V perpendicular is v sin theta. Therefore radius of the helix will be mv sin theta divided by qb. This is the formulas that you have to remember if the charge particle is moving at an angle. Charge particle ഒരു ആംഗിളിലാണ് നീങ്ങുന്നത് വെച്ചാൽ അതൊരു ഹെലിക്കൽ മോഷനിലായിരിക്കും. ആ ഹെലിക്കൽ മോഷന്റെ pitch of the helix കണ്ടുപിടിക്കാനുള്ള ഫോർമുലയാണിത്. And the radius of the helix is obtained by this formula. Hope you have understood this session. Then now we will speak about the concept which is called as velocity selector or velocity filter.